All right, so today we're talking about rational exponents, and rational exponents come right after radicals for a very specific reason. I can rewrite any radical that I see with any index number as a rational exponent. Now, first of all, we need to know what a rational number is. Who can tell me what a rational number is? Who can tell me what an irrational number is? Who can tell me what a number is?
Isn't it rational number or like? No, irrational, like point, like has like 0.1113 or whatever.
Okay, are you talking about rational or irrational?
Rational is one up, ain't it?
Rational is one up.
Like
Like
real
real
numbers?
decimals or something?
Okay, now we're getting somewhere. So I heard whole numbers, I've heard decimal numbers, and Sam's giving me 0.1113 something. Okay, so he's giving me decimals as well. So whole numbers are what numbers? 1, 2, 3, 4. What's integers?
The negative version of them.
The negative version and the positive, right? So integers are the numbers you usually see on the number line as your big tick marks, right? So -8, -7, -6, 0, 1, 2, 3. Those are your integers. So what's a rational number?
Positive numbers.
They're positive. They can be negative.
Again.
They're any numbers that can be written as a fraction. So tell me what,
All of them.
give me an example of a fraction. Not all of them.
Put under.
Not all of them. Can 0 be written as a fraction?
Yeah, you can try hard enough.
Yeah, how?
Put a line under.
0
Zero.
over
1.
1. Is 4 a rational number?
Yeah. Put a
Why?
line under, put a 1 under.
Because
you got a
4
fraction.
over 1, and I have a fraction, right? So all of those are rational numbers because any whole number or any integer number, so if I had -5 over 1, that's a rational number. Give me another rational number that doesn't have a bottom of 1.
1 over 4.
1 over 4. A half. 1/3.
2 over 8.
2 over 8. 13 over 17. Any of those negatives, 24 over 100, any of those are rational numbers, okay? Now, so let's write this. Write this in your blank, please. A rational number is any number that can be written as a what?
Fraction.
As a fraction. A fraction has a numerator and a denominator, so a top and a bottom. Now, think back a long time ago. What can never be written as a fraction?
That fraction does in the
It, improper fractions is a rational number because even if it's like 24 over 3 or 24 over 15, it's still a fraction. Come on, what number? You learned a long time ago. It always
One.
repeats. It doesn't repeat and it doesn't terminate. Pi. 3.14 blah, 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 right? We could die saying all of the numbers because they never end. They go on forever. So in your calculator, if you have, let's say, can y'all see that? Let's say you have 25 over 6. And I hit enter. Do you see how that gives me a whole number and then a decimal? But if I go to this fraction, this math, enter, that's going to give me the fraction form of that number, right? But let me do pi. Second pi. Hit enter. That gives me a whole number and a decimal. Let's try to change that to a fraction. It won't go. Okay? There's no fraction that represents pi. Same thing with a number called e. There's a number E, it's on your natural log key, the LN key. If I try to turn that number into a fraction, it will not go. Okay? What else do you think is irrational? Something that we've been doing the past 2 days.
Red.
Radicals. Now, not all radicals. What about the square root of 25?
It's 5.
It's 5. So will that go into a fraction?
Yeah.
Okay, what will not?
Cube.
What else? Radical.
Cubed root of what?
3. That's 1.
Cubed root of 3?
You know what that is?
Cubed root of 3 will not go into a fraction. Why? Let's do one a little bit easier, okay? Let's do the square root of 15. Is that rational?
No.
Square root of 25 is. Why isn't the square root of 20? Why isn't square root of 15 rational?
Because it don't have a whole number if you do all that.
It doesn't have pairs in there. So 15 would break down to 5 and 3. Could I pull anything out? 5 and 3, can I pull anything out? Do I have twins? Hey, do I have twins?
No.
No, so I can't pull anything out. So if I did the square root of 15, watch. That gives me 3.8 something something, and I do a fraction, and it won't go into a fraction. Well, what about the square root of 25? Well, that's whole already, isn't it? So if I have pairs and all numbers come outside, it's a rational number. If I have numbers still left under the radical, it's irrational. Does that make sense? Okay. A rational exponent is therefore a, what do you think? What do you think a rational exponent's going to be?
Decimal.
Read this. A rational number is any number that can be written as a fraction. So, the exponent is a, say it one more time, Trevor. Fraction. All right, so write fraction for me, please. A rational exponent is another way of writing a radical,
Oh.
also known as a root. No, that's not right. Sorry, that would work, but I wanted to write an index number. Sorry. It's the index number because what did I tell you? A 4 as an index is called a fourth root. Okay? The blank of the fraction indicates the root. So you're not going to know that blank, but it's the denominator. The denominator of the fraction indicates the root. Now, this is super simple. Okay? So just pay attention, and it's really just a process, okay? All right, so your first example, how would you say this? How would you have said this Friday or yesterday? What is that?
X times it.
The square root of x, right? Could that break down anymore?
No.
No, because what's the index number? 2, because it's not there. How many x's do I have inside? 1. So can I make a group of 2?
No.
No. But what we're learning today is what's that exponent on that x?
1.
There's a 1 right there. If it's an understood 1 if I don't have an exponent. What's the understood index? 2. So watch what I'm going to do. That's going to be the same as x to the 1 over 2. So that radical can become a rational exponent by doing the exponent of the variable over the index number. Are you with me? Questions? Let me prove to you that's the same. How could I prove to you that that's true? something you know the square root of?
25.
25. So I'm going to do the square root of 25. What's that going to be? 5. What would be the equivalency of the square root of 25? 25 raised to the what? What's the exponent on the 25? What's the exponent on the 25?
1.
1. Because is there an exponent on the number?
No.
No, so it's 1. So 25 raised to the 1, what's the index of this?
To the second.
2, right? So 1 over 2. What's going to happen when I hit enter if I'm telling you those are equivalent?
It'll be 5.
It's going to be 5, right? So the square root of 25 is the same thing as 25 raised to the 1/2 power. Does that make sense? Okay, let's see if you can do this next one. What about example 2? Write what you think that is. What's the exponent on the x? 1. So what do you think this becomes?
1 over 3.
X. It doesn't become 1 over 3. It becomes x
1/3 power.
to the 1 over 3 or 1/3 power.
Because the 3 goes up and goes underneath.
The 3 goes underneath. Always. Very good, Sam. All right. Ooh. Okay, what you think about this? What's equivalent to x to the 1/4 power?
Index for radical x over to the 1.
Index 4,
Then just x.
just an x. Do I have to put to the first power?
You can, but it'll still be the same.
Right, I can, but I don't have to. Are there any questions? All right, Tiva, can you do example 4 for me?
Yeah. It's 7 where the thing is. You know what I'm talking about?
7
Yeah.
as the what? Starts with an I.
Index.
Index, okay, good.
And then it's X inside.
X inside. Awesome. Can any of these be broken down? Like, am I going to have groups of X's that I can pull out of any of these?
Yeah.
Of these 4?
No.
No. Because how many groups do I have to take here?
4.
4, there's only,
1.
how many groups do I have to take here?
7.
7, there's only
1.
1. Now that's tricky to look at, right? If I'm reducing, my brain can't do that reducing. I have to see it this way. Okay? Questions? All right. What about these? If the numerator of a rational exponent is not 1, then the radical is also being raised to a power. This can be written 2 different ways, and I'll show you what that is.
Would be 3.
Index of 3.
Then there'd be x squared inside. X squared.
Okay. Index of 3. X to the
Second inside.
second inside. Awesome.
Equals what?
Now, how can I write that? We have to go back to lesson 2. Lesson 2 was properties of exponents. So there's one more way I can write this, and I'm going to write it and see if you can figure it out why that's equivalent. I can write 3x raised to the second power.
Could you tell me everything?
I don't like times and everything by 2.
Multiple.
I'm raising everything by 2, right? So how could I rewrite the third root of x? How could I rewrite this right here? Ignore the 2 for right now. Cubed root of x could be the same thing as what? This could be x to the 1/3 raised to the what? Second. Now what do I do to the third times raised to the 2?
Raise 1/3.
What's 1/3 raised to the 2? What do I do there? Power to a power. I'm running out of time. I got 15 seconds. Power to a power. I have 1/3 times 2. What's a third times 2? 1/3. Bless you. 1/3 times 2. is 2 over 3, so that's